Good morning, everyone. This is Rokalabana Vevyas from Aeronautical Engineering B section. Today, my topic is object variables. First of all, after going into topic, we'll be seeing what OOP, object-oriented program terminology. Overview of OOP terminology. Class: a user-defined prototype for an object that defines a set of attributes that characterize any object of the class. The attributes are data members, class variables, and instance variables and methods accessed via dot notation. Class variable: a variable that is shared by all instances of a class. Class variables are defined within a class, but outside any of these class methods. Class variables are not used as frequency instances or class variables and instance variables and methods accessed via dot notation. Class variable, a variable that is shared by all instances of a class. Class variables are defined within a class, but outside any of these class methods. Class variables are not used as frequently as instance variables. Data member, a class variable or instance variable that holds data associated with a class and its objects. Here, overview of OOP terminology. Class. After that, when we go into this data member, a class variable or instance variable that holds data associated with a class and its object. Function overloading. The assignment of more than one behavior to a particular function. The operation performed varies by types of objects or arguments involved. Instance variables, a variable that is defined inside a method and belongs only to the current instance of a class. Inheritance, the transfer of the characteristics of a class to the other class that are derived from it. Instance, an individual object of a certain class. An object that belongs to a class. Circle, for example, is an instance of the class circle. Instantiation, the creation of a instance of a class. Method, a special kind of function that is defined in a class definition. Object, a unique instance of a data structure that's defined by its class. An object comprises both data members, class variables, and instance variables and methods. Operator override, the assignment of more than one function to a particular operator. Here, when we go through the creation of a class is created with the keyword class and then writing the class name. The simplest form of class definition looks like class name, statement 1, and after statements up to statement 10. Class definitions like function definition definition statements must be executed before they have any effect. You could have conceivably placed a class definition in a branch of an if statement or inside a function. Class student def in itself. Self.name is equal to self.name is equal to Hari, self.branch is equal to CSC. Then we have to use def display of self, and after that print self.name, print self.branch. After executing this program, we'll be getting Hari and CSC. Like this, we can create a class object variable. For example, if we student class, we can write code in the class that specifies the attributes and actions performed by any students. When we go through this self variable, s1 is equal to studio. The self variables is used as for first parameters in the constructor as def, init, and self. In this case, self can be used to refer the instance variables inside the constructor. Self can be used as parameter in the instance methods as def display of self. Here, display is an instant method as it acts on the instance variables. If the method wants to act on the instant variable, it should know the memory location of the instant variable. The memory location is by default available to display method self. Constructor def self.name is equal to Hari dot self dot branch is equal to selfie. S1 is equal to student. Def init self or n is equal to b is equal to self name is equal to n self branch. When we execute this program, we'll be getting n and b. Here we'll see one example. Class, we have defined a class which is defining about a student. Class and student. Def init self comma n is equal to b is equal to self dot name is equal to n and self dot branch is equal to b. Def, again we should do def display of what we are doing. Self print hi comma self dot name, print branch dot self branch. S1 is equal to student of s1 dot display print. S2 is equal to no. After printing, we'll be getting hi and branch and hi Mohit branch CSC. Types of variables. There are two types of variables: instant variables, class variables, or static variables. Instant variables. Instant variables are the variables whose separate copy is created in every instance. For example, if x is an instance variable and if we create three instances, there will be three copies of x. In these three instances, when we modify the copy of x in an instance, it will not modify the other two copies. A Python program to understand instant variables. First, we will be defining a class sample definite self dot x is equal to def modify of self dot x is equal to self.x plus 1. S1 is equal to sample of sample, S2 is equal to sample. Print x in s1 is equal to s1 dot x, s2 dot x, s1 dot modify. We are modifying it. First it will be x in s1 is equal to 10, x in s2 is equal to. After that, here we have used self dot x plus 1, means the it will be adding to the to those to that S1. See, after output is exit S1 is equal to 11, and here we have used S1 dot modify. It will only modify the S1 sample. So 10 plus 1 is equal to 11. So here we are getting the output 11 and 10. And next we'll be going into class variable or static variable. Class variables are the variables whose single copy is available to all the instances of the class. If we modify the copy of class variable in an instance, it will modify all the copies in the other instances. For example, if x is a class variable and if we create three instances, then same copy of x is passed to these three instances. When you modify the copy of x in an instance using a class method, the modified copy is sent to the other two instances. Here we'll be seeing one example. A Python program to understand class variables or static variables. Class sample. We are defining a def function. X is equal to 10. At the rate class method def modify class. Again we are adding one. Here we are modifying S1. So again see first it will be printing x in S1 is 10 and x in S2 is 10. And after that we are only modifying the S1. So here we are modifying S1 as well as here class variables means it will add two numbers. So class in x in s1 is equal to 11, x in s2 is equal to 11. After that, namespaces. A namespace represents a memory block where names are mapped to objects. N is equal to 10. Here n is the name of given integer object 10. Class namespace. Class student n is equal to 10. Print student dot n. Student dot n is plus is equal to 1. Print student dot n. Here displays 10, 11, 11, 11. As we are adding n to plus 1 to the final product, we are adding plus 1. So it will be printing display 11. Instant namespace. Every instance will have its own space called instant namespace. In the instant namespace, the names are mapped to the instance variables. Every instance will have its own namespace. If the class variable is modified in one instance namespace, it will not affect own namespace. If the class variable is modified in one instance namespace, it will not affect the variables in other instance namespaces. To access the class variable at the instance level, we have to create instance first and then refer to the variable as instance name. Variable. Types of methods: accessor methods, muter methods, class methods, static methods, instant methods. Instant methods are the methods which act upon the instance variables of the class. Instance methods are bound to instances and hence called as methods. Need to know the memory. Here we'll see one example. Oh. Inheritance. Software development is a team effort. Several programmers will work as a team to develop software. When a programmer develops a class, he will use its features by creating an instance to it. When another programmer wants to create another class which is similar to the class already created, then he need not to create the class from the scratch. He can simply use the features of the existing class in creating his own class. Deriving new class from the superclass is called inheritance. Means we can modify the already written program without creating from starting scratch. This is called inheritance. The child class inheritance the attributes of its parent class, and you can use those attributes as if they were defined in the child class. The child class can also override the data member and methods from the parent class, subclass, class body. The super method. Super is a built-in method which is useful to call the superclass constructor or methods from the subclass. Any constructor written in the superclass is not available to the subclass if the subclass has a constructor. Then how can we initialize the superclass instance variables and use them in the subclass? This is done by calling superclass constructor using super method from inside the subclass constructor. Types of inheritance. There are two types of inheritance. Single inheritance, multiple inheritance. Single inheritance. Deriving one or more subclasses from a single place is called single inheritance. In single inheritance, we will always have only one base class, but there can be an n number of subclass derived from it. For example, bank is a single base class from where we derive Andhra Bank and State Bank as subclass. This is called single inheritance. Example, cash is equal to 100 and class method. And after that, multiple inheritance. Deriving subclasses from multiple or more than one class is called multiple inheritance. All the members of superclass are by default available to subclasses, and the subclasses in turn can have their own members. The best example for multiple inheritance is the parents are producing the children and the children inheriting the qualities of the parents. These are the some these are the total glance of the class object variables. Thank you.